The last presentation of the first EIC day is going to be about the future, namely future of identity and access management using algorithms. This sounds something in my mind back in my computer science studies as something that optimizes the data usage for specific purposes. And I'm very interested to learn about that. Welcome, Patrick Parker.
Thank you. Good to see you. Hello, everyone. I'm Patrick Parker. I'm the CEO of EmpowerID. Happy to talk to you today. My talk is about the revolution that's going on right now using machine learning, artificial intelligence to optimize business processes, gaining efficiency, and providing better customer service. Do I have a clicker? There we go. Okay. So start out the story. Recently, March 15th, there was a competition, the Google DeepMind Challenge, pitting the 18-time world champion of the game Go, which is an ancient Chinese game. Some think it's the most ancient of all games, against a human being. So the Google team developed AlphaGo. AlphaGo was developed by 100-plus scientists. It had 1,202 CPUs, 176 graphics card processors, and all of the latest machine learning algorithms, specifically using neural networks, to calculate strategy to play against a human being. The best experts in the industry estimated that machines were at least 10 years away from being able to challenge a competent human being in the game of Go. So what is machine learning? Machine learning is the ability to program computers so that they can learn and improve their own processes without being explicitly tasked with all the steps in the process. So for example, the AlphaGo could learn by playing games against itself or games against others, and it would get better. And even the programmers who wrote it could not predict how it would choose its next move and the strategies that it would employ. So the game started out, Lee Sedol against AlphaGo. Very quickly in the first match, AlphaGo was the winner. A lot of people were really shocked. They thought maybe it was a fluke, but seeing how it goes. Second game, AlphaGo made some very interesting moves that no human player would ever make. Some of them were seemingly as if AlphaGo had a malfunction, but really what they found out was that it was a very crafty strategy where it was feigning weakness in order to lure Lee Sedol in until it made a killing move. So at the end of the fifth games, Lee did win one. They chalked it up to a Monte Carlo simulation error in AlphaGo, but the AlphaGo was the winner. So for the first time, 10 years ahead of schedule, a machine had beaten a human in a game which is considered more strategic and relying more on what we would call human intuition and strategy than any other game, even more than chess. So that really could be considered, well, the machine beat the human, maybe that's a downside, but really humans designed the machine. So that is a benefit to all of us that technology has progressed at a much faster rate, especially in the last 2 to 3 years, than anyone had predicted. So a recent study by Harvard Business Review, there are actually two this year, about the application of machine learning technologies to various business challenges to measure productivity. How could it improve our business processes? So what they analyzed was how it could affect processes that were automated, processes that typically might have been manual or involving a lot of human interaction that could be automated by machine learning, where machines could think like humans, they could understand human language, natural language, and they could make their decisions on their own. Now, this whole process automation goes by many names. Service delivery automation is what a lot of people call it. And each of these have a different nuance. Robotic process automation, which is non-human interaction with applications to automate. The ones you might hear a lot about are machine learning, which is probably the most common term these days, using algorithms to optimize processes and solve problems. And then cognitive computing is probably the one that you'll hear the most about coming up, because that's the term that IBM has landed on, and that's the term that Microsoft has recently landed on, and they've really made major, deep investments. Microsoft, at the Build conference, said that was their key strategy going forward, and they're putting all their investments, or not all their investments, but a lot of their investments on cognitive computing. So when they looked at these 30 pilot companies at the various parts of the business, so the managing customer service, managing enterprise risk and compliance, which we're all very concerned about, developing and managing new business capabilities, marketing and selling products and services, and then they looked at each of the types of machine learning algorithms that could be applied. They found that for these 30 companies, that which ones were the most effective at producing a value. And typical gains, when in the 30 companies, they mapped it out to these various areas, with managing enterprise risk and compliance mapping to some natural language, which is the understanding of human speech, a lot of anomaly detection, which we would guess. That's what your SIEM solutions, your intrusion detections use to try to ferret out behavior. Predictive analytics, which is also used in those technologies, and then the visual sensing, which is the ability to recognize human faces, to recognize objects, and to map what they are. Well, what they found is that out of 168 companies, those companies averaged an improvement of 2 to 10 times of the speed in their processes. So really, really big gains, which means money to the bottom line, by using these advanced technologies that are just really now coming to fruition. So diving into those, natural language processing is a really big one. It's probably one of the biggest right now. You all know Siri. Microsoft has Cortana, so the ability to understand natural speech from a human and interpret the meaning of that, and the ability to speak back. In Big Blue, from IBM, they have their tone analyzer, their Watson tone analyzer, which is really interesting. It can analyze an email or any text and rate it as far as how friendly it is, how aggressive it is. So you can proof your own emails to see if it sounds you're being a nice guy. Or you can measure across all of your employees or your customer service to find out who is not sending out emails in a good tone. So it can even get down to the level of gauging human emotion. So there's a lot of information here, and this is really used by a lot of the automation, the bots, where you're interacting with what you think is a human being, but it's actually not a human being. I did a little test. Of course, no machine's perfect. You have to set the machine to solve the right problem. So Big Blue has, we can ask questions about the weather. Well, if you ask it, does it taste like pizza? It can give you weird results. It thought that I was definitely 94% confident that I was asking some question about temperature. So you always have to think, am I putting the technology against the right problem and working within the parameters? I don't think it was ready for the pizza question. So also in natural language processing is speaker verification, where you can voice identify that this person is, like an authentication of that person. That's speaker verification. Speaker identification is if you hear a lot of noises or a crowded situation, identifying that these are the people, matching multiple voices in a conversation to individual people. That could be used in a lot of security, especially government applications when sampling very large volumes of recorded sound. Now, the amazing thing is that this extremely advanced technology is becoming ridiculously cheap. This is from Microsoft. They just made a big announcement. They launched their Cognitive Services API. So pretty much anyone can plug in machine learning and cognitive services into their applications. This is the pricing for the natural language processing. So 0 to 50,000 transaction level, you're paying $5 for 1,000 transactions. Which is, if you count the cost of any human customer service interaction, if you count the cost of, let's say, a password reset to the help desk, you can see how very, very quickly you can save a lot of money. So visual sensing is detecting both faces, detecting objects. I think IBM has one, or it's Microsoft, I forget which, where they can even detect from photos celebrities, matching it against a celebrity database. So you can scan all the photos to find celebrity shots that you didn't know were there. But there are obviously more, better uses for this, face authentication, other types of applications. So one example of a use of this that's super, super high volume, super real world is for FINRA. FINRA is actually a customer of ours. They're the regulatory agency for the NASDAQ. So they have to detect fraudulent trades, insider trading across multiple stock exchanges. So they're basically looking for the proverbial needle in the haystack of all those transactions. They're looking for something that was fraudulent, which there's so much money incentive there, of course they're going to try to slip it through. So they use machine learning to analyze 75 plus billion market events every day, hundreds of algorithms to try to sift through all that data to find insider trading or fraudulent trade. So very, very effective. Outlier detection is the ability to analyze data to find which one doesn't fit. So this is often used in security analytics to try to detect someone's behavior falls outside the norm. It's also used traditionally in identity management for role mining to find, okay, these people cluster into these job functions and roles, but then this one person just really doesn't fit. Typically, it's because that person's been in the organization and changed jobs, so they just accumulated things they shouldn't have, but that sometimes it could lead to some type of security investigation to see why they have something they shouldn't have. So the general idea, if you boil it all down, the whole machine learning is that you just need to collect the dots. Collect everything. Lots of data. The more data, the better. The more accurate it's going to be if it has more data to work with. So you collect the dots, but of course, there's so much information the human mind can't process it. So you use the machine learning algorithms to connect the dots, to look at that vast amount of information and find the patterns, to find the information that your brain could never process and an army of people could never spend enough time to uncover what a machine can uncover extremely fast. So why is this all becoming possible? There's been a technology explosion in the last couple of years. I mean, really rapid evolution. If you look behind the scenes, technologies to analyze large volumes of data that could never be analyzed, and also even more fascinating in some ways, to analyze real-time data, thousands to millions of events in real time as they're coming through, and building those predictive models to determine what's happening without having to wait till later where it's less actionable. You can actually take action as it's happening. You can avoid an event. You can make decisions before a customer purchases or before something happens. So what kind of data? Basically anything that your traditional SIEM, like Splunk or IBM or any of them, anything that they would gather and analyze is what are the dots, the things that you'd want to analyze. Logs, events, click tracking, your firewall traffic, pretty much anything you can pump in for analysis. So with this huge volume of data, we're really looking at a different way of looking at it, analyzing it, storing it. Traditionally, you have the data warehouses where you're taking all the data and you're trying to normalize it into a structured, common SQL format. Now there's so much data that it would never even be possible. Now it's more of what they call a data lake, where you have a repository that you throw the data in its natural format, and then it's optimized that these algorithms and processes can crawl through it and analyze it without it being formatted or modified. So the data lake is really multiple consumers can process any of that data because it is in a standard accessible format. And it's very cheap as well. So we're moving beyond, the paradigm shift is before it's better tools for humans to look, visualize, and understand. We're kind of moving to somewhere where it wouldn't even be possible in all cases for humans to understand. It's beyond the mind's ability to comprehend the amount of data, 1.7 megs by 2020 for every human being on the planet every minute of the day, 44 zettabytes. I mean, there's a ridiculous amount of data that there's no way we could even understand it. So jumping ahead. So role mining is a good example. Analyzing the access that people have. Your brain can't deduce it down into patterns. It's too much. You need algorithms to look at the data and to find the clusters, who are the same, who matches, to uncover the hidden patterns. And of course, this presents a lot of opportunities for traditional workflow, thinking about approvals, how many approvals, automatic dynamic approval based on predictions and patterns, risk-based, requiring more approvals, but probably the more interesting application and the one where everybody's investing is not on the traditional workflows, but what are becoming known as service bots or service automation. So the word robot, before 1920, the word robot meant forced labor. It was a feudal term that was, the term was out. The forced labor was outlawed by the Austrian Empire in 18-something. But until 1920, that's what it meant. But in 1920, Capek, who was a Czech writer, wrote a play where it was called Rossum's Universal Robots. It was the first use of the term in that manner. They were semi-organic. They were built together. They had the first robot uprising. So this is really the start of all of the genre, the Terminators, all the movies that were well, we all like. I think you like them probably too. What was this idea? So now, moving ahead, the first actual robot was in 1959 in Sweden, which was, it's the first robot. Very primitive, very heavy, just to move a mechanical arm. Now, and that's where everyone saw the explosion, lots of mechanical robots. But what they found is that there's really a paradox. What you'd think was extremely difficult is actually easier than what you'd think is easy. So they found that it requires a lot more computation or computing power to move and have a robot walk like a human and not fall down. That's why they're always so clumsy. But making a robot think like a human mind is actually much, much easier than having it do simple motions. So that's led to the explosion in technology called service robots. And service robots are the ability to have computers think like humans, understand human speech, make decisions without a human being involved. And I'm running low on time, so I'll try to speed it up. So this is really considered the next revolution. The first revolution was the physical, the steam engine. The second was the computing. And the third is kind of a mix of artificial intelligence, robotics, to take us into the next level of productivity. Lots of information as far as how much time saved, how many full-time employees saved. In some cases, for example, the NHS is able to close 180 sets of accounting books every month in just 4 hours using this technology. A major bank saved over 120 full-time employees. And you'll have cases like a service desk robot answering 62,000 calls a month, just things that a human could never do. But they can, if there's a pattern, if they could figure it out, it's faster and it's definitely a lot less expensive. I think a service robot costs 1/9 of an employee in the United States or the UK. So it's huge cost savings. So you imagine the service robots at some point, they're in your computers, they're around, kind of like our little friends from Star Wars. They're doing tasks, they're thinking on their own. And that's the big difference. It's not a drone where a human has a joystick and a remote control. These are making decisions and doing tasks without any human interaction on their own. So taking that a step further, you could even think of the Sentinels in the Matrix, security bots that are crawling and looking for patterns on a search and destroy mission. They know what's right, what's not right. They could shut down access. They could log you out. So just taking that a step further, Slack, which is a super popular messaging application right now, instant messaging, collaboration, they have Slackbot. And Slackbot allows you to work out workflows like this, where you are talking to a bot, and a bot is doing things like detecting events, like a new customer, creating a Salesforce record, sending an email, interacting with all your systems to automate very sophisticated processes. So if you could imagine opportunities in identity access management, account lockout bot that talks to people when it detects a lockout from a system, why wait for them to call the help desk? Why not have something reach out to them proactively? I'll talk about that one. Real-time access certification bots. Bots crawling around looking at the data and making decisions and getting tasks done so that humans don't have to wait for that to get done or to do it themselves. So kind of an account lockout bot. Maybe, hello, Bob, I detected an account 5 failed login attempts. It could reach out and instant message them to say, was this you? Are you locked out of the system? Please give me your one-time password, and it could unlock them. So you could have, replacing mundane, repetitive help desk calls with very intelligent interaction that gets it done quicker. So, of course, we have to guide these robots properly. We have to build them for the proper processes. And, of course, there are ethical and legal concerns. As soon as you're letting loose these bots that can make decisions on their own, you really need to treat them as a different type of identity, because they're no longer acting on behalf of someone. They are someone. So their rights and access need constrained, because you don't want them going wild and accessing too much data in the data lake, performing actions against people. So it's a whole new area of concern for identity management, but there's so much benefit that the money makes sense. It's just going to happen. It's in the process of happening, and it's going to happen. Thank you.
Thank you so much. I think you made a good point. This is the future. This is to come, and whether we like it or not.
Yeah.
I think you made a good point. Just repeat, because my micro wasn't on. You made a good point. This is the future. It's going to come whether we like it or not.
Faster than we thought it was.
Yeah. Nevertheless, there's one question. Could you please put up the question slide? There you go. What is your view on autonomous computing? Should people keep control, or can we trust the computers that we build? Think about the go unexpected move example.
It's a complex question. I think even at Facebook, where they have the messenger bot, the most complex questions are answered by a team of humans. So it's almost like you need the machine learning to answer the questions, but then there's going to be, or to perform the action, but there'll be such a high volume that you'll probably need machine learning to identify the ones that shouldn't be answered by machine learning and routed to humans. So it's a little bit of a mixed answer.
Yeah, but we will see.
We
keep control. Right?
We shall see. We shall see.
Yeah. Thank you again, Patrick.
Thank you, everyone.